All right, sorry, I like to pace around a little bit. Okay, so Renee and Andy asked me to give this talk, I think, to get us all on the same page about just what are the general environmental conditions that we are trying to survive here. And then we'll all go into later, why do we want to survive them? Why can't we get all our science done in a single day? And then, the how of surviving them. Okay, so we're just going to go through kind of the unique lunar environmental conditions, some of the big ones being, of course, temperature variations, illumination considerations, and then just touching on kind of plasma charging processes. And then those really kind of key in on three unique areas or times, equatorial or really kind of just mid-latitude, day and night, the terminator, right, at dawn or dusk, and then the polar regions. So a lot of this information comes from the Diviner Lunar Radiometer experiment that's on the Lunar Reconnaissance Orbiter. The PI of Diviner is here somewhere. The PI of Diviner is here somewhere, Dave Page. Oh, waving over there so you can ask him questions. Is this too loud now? No, okay. So that instrument measures bolometric brightness temperatures that are calculated from 7 channels between 8 and 400 microns, and then gives us this look at the surface, scrolling through here, where you have daytime maximums that are nearly 400 Kelvin. I've included Fahrenheit just for some more human reference for us Americans. And then the nighttime minimums right before sunrise that are around 95 Kelvin. Of course, those days last around 2 weeks, nights also 2 weeks. And these plots are from Jean-Pierre Williams, and they show how that varies by latitude. So as you can kind of see on the previous slide, you don't, until you get to very high latitudes, you don't buy yourself a lot of relief from noon. And is there a pointer here? Well, there's so many screens, pointing might not be effective. But you can see at these the low latitudes that are, this increases in latitude as you go down here, you have pretty steep curves here, and then it's not until you start getting to really above 60 degrees that you're seeing some decrease. And then as you get toward the poles, you have noon maximums, but also then this and the nighttime isn't down around 100 Kelvin, it's up more around Mars nighttime kind of conditions. You don't escape the brutal noon temperatures, but hey, that's not so bad. Of course, nothing is perfect. This is that crater. You have 20-degree slopes, and those are covered with boulders 20 meters and up and down. So, if you can find land or power challenges, of course. It's important to still note, though, for kind of operational purposes, there are significant sources of illumination, even at night. There's Earth. I don't know, I didn't have time to fact check that Earthshine is equivalent to a 60-watt bulb 6 feet overhead, so not insignificant. When you get toward the terminator, you have, of course, a special environment. Part of that comes from just the contrast over a short distance that you're seeing. So on the day side, you have a positively charged surface. You can see in this diagram from Tim Stubbs, you can ignore some of this extra crazy stuff going on here, but this main thing to note is here, all these pluses on this, just showing how those change. And, you know, you do have a similar thing else positive, so you get free cryogenic storage. Fantastic. Bonus. No need for active cooling of your instruments. Great for all kinds of astronomy. So to summarize, you know, we do have all of these distinct considerations that we have to keep in mind in each of these locations. But we understand them very well. That was, you know, one of the main drivers for the Lunar Reconnaissance Orbiter. It was designed to provide all of this information that would be needed for future surface exploration and operations. And so none of these are, you know, conditions that we can't overcome. And I think we just need to keep in mind that, you know, we can do this. This is a challenge, and we can do it. So it's easy to talk about all of the challenges and become fixated and stuck on those, but yeah, we, you know, these are overcomable. All right, thanks. Okay.
I presume you want to speak.
Oh, there's something that you're supposed to pass around.
So, Dean Epler, Aerospace Corporation, that 6 foot, 60 watt bulb is work I did in 1990. I'm responsible for that.
Fantastic.
It's in a TMX that was published long before most people in this room are alive. And the first time it's really seen the light of day is a poster that's just hung out. But the thing I think that's important is rather than think about a 60 watt bulb, everybody that lives in some place that has summer, about middle of July, about 8 in the evening, is what Earthshine is like. And John Young told me that from orbit in Earthshine, you can see color differences on the lunar surface. I mean, you can actually see them from 100 kilometers in Earthshine. So it's really remarkably bright. At the sub-Earth point, as you move away from that, it gets progressively poorer. But that's in that poster, so I'm doing a shameless plug for my poster.
Thanks. And yeah, I think sometimes there are cases where, you know, operating in the night under those kinds of illumination conditions can be simpler than, you know, the very extreme conditions that can occur early or late in the day.
Okay. All right, at this time, I would like to welcome up our next speaker, Ron Creel. Some of you may know him as Roving Ron. He worked on the Apollo lunar rovers, the ones the astronauts drove around in. And he's going to give us a presentation on lessons learned from missions that have survived and operated through the lunar night. Ron, take